Does this look like your game? Are you wondering why it doesn't capture the charm that other pixel art games have? Something's off, but you can't put your finger on exactly how to fix it. I might be able to help. Without pixel art, the gaming world as we know it wouldn't exist. The very first video games relied on a form of pixel art, and over the decades it has become a timeless staple, evolving from the arcade classics to titles like Mario and Zelda, even inspiring modern masterpieces like Stardew Valley and Dead Cells. Maybe you're like me, you've dabbled in pixel art, dreamt of bringing your game to life, but for some reason your work just doesn't feel quite right. Now, you could be the best artist in the world, but you could still make these mistakes when putting the art into your game that drags the quality down heaps. So how do we fix it? Well, today I'm going to give you some tips that I have learned over the last few years and even more so in the last few months. Now, disclaimer, this isn't a pixel art tutorial. I'm not a pixel artist and I don't claim to be, but even if you're getting assets online, you can still fall into certain traps that can cause even the best art to look bad in a video game. For example, I've been working on a project since January 2023, and the original art for it looked like this. And more recently, after applying the steps I'm going to share with you, has taken the art to look like this. Now, I'm still largely in the early stages of the art and visuals for this project, and it might not be completely obvious. Like I said, even experienced artists are going to struggle with this, but there's a few things with pixel art that if you don't get right in the early stages of development, your project will be stuck looking like a pretty bad indie project. The first thing I want to talk about is constraints, because it will be a common theme in pixel art to be working within a constraint. Whether it's the size of the canvas, the amount of colors you pick, or the resolution that you decide on, working within a constraint and sticking to that constraint will not only elevate the look of your game, but will also help you better understand certain decision making with the design of your game. Modern game engines spoil us. Truly, they allow us to work outside of any constraints, and in doing so, you can pretty easily develop bad habits. Let's take a game engine like Unity. I use this on a daily basis, and until recently, I never fully understood the resolution options. I understood it on a fundamental basis, like if you're developing for a specific platform like mobile or console, but I never really understood it more than that. You're given the default resolution, which is generally 16:9 or 16:10, and for most cases, this is sufficient. But if you're doing a pixel art game and you're not thinking about the resolution, then you can very easily fall into the trap of a pixel art looking game that isn't actually technically pixel art. Let's step back for a minute and look at a game like Final Fantasy Tactics Advanced. This is an incredible example of a game following the pixel art constraint, and in extension, it's just a pretty looking game. But how do they make it look so damn good? Well, to truly understand the constraint of this game, we need to understand the constraint of the platform itself. In this case, the Game Boy Advanced. The actual hardware resolution is at a 3:2 ratio, or more specifically, 240 pixels by 160 pixels. That means everything you see on this screen here is 240 pixels wide and 160 pixels high. No more, no less. That is our constraint. Now, a good reference to use for finding your resolution is this website here, which gives an example of true 16:9 resolutions. And to extend on this website also gives you the resolutions which are also divisible by 8, which for almost every case of pixel art is what you're looking for. You might notice that Final Fantasy Tactics Advanced's screen resolution of 240 by 160 actually doesn't fit here, and that's because they're using the 3:2 ratio. But a good starting base to use 16:9 is because it fits most, if not all, modern screen sizes, whether that's a computer, a tablet, a phone, or a TV, in both landscape and portrait mode. Now, realistically, it doesn't make sense for a pixel art game to be 1600 by 900. That is way too much detail, and you'll be surprised with how much detail you can get away with in a much smaller scale, as long as you're following these constraints and rules. Now, as a side note, just because you're designing it at a smaller resolution doesn't mean that the screen size will be smaller too. If you design it by this resolution guide, on the actual executable, the screen size can go to the native display size while maintaining an accurate pixel ratio. So, step 1, choose a resolution and stick to it. For today's example, we will use Final Fantasy's 240 by 160. Next, let's find a good canvas size to use. When I make my pixel art, I use Sprite. It's extremely easy and straightforward to use, but there's plenty of alternatives like Photoshop, or if you're feeling dangerous, Microsoft Paint. But how do you find the right canvas size to use? Well, part of it is about finding what suits your game. What pixel per unit value will represent one unit size in your game? And I'm using Unity's naming conventions here, but I know RPG Maker has similar values and Godot has their own as well. Well, let's start by actually recreating our target resolution inside of our art software. And let's continue to use Final Fantasy Tactics Advance. Like I said, they use 240 by 160. So let's create a canvas at that size. And just for reference, I'll copy an in-game screenshot off Google and paste it into this canvas, and you can see it fits perfectly, not a pixel out of place. Now we can start to break down this reference. This game is designed in an isometric perspective, so let's keep with that. Let's create a new layer that we can draw on top of without obstructing the original layer, and start mapping out the tiles. If we draw out the isometric tile like this, we begin to see the actual size that it fits into, which one tile wide is 32 pixels. That is our pixel per unit reference, and that will be our size guide. Again, I want to note, as someone learning like I have been, just because our pixel per unit is 32 doesn't mean every canvas we need to create needs to be divisible by 32. So it doesn't need to be 32 by 32. We can take it out of that and design something at say 32 by 48, or 48 by 48, 64 by 64, or even take it smaller and do 16 by 16. And there will definitely be cases where this happens, but this is perfectly normal and to be expected. Even looking at some of the art in this screenshot, we can tell that they are designed on a bigger or smaller canvas. Let's quickly mock up a tile and a character. Now that we have sort of a foundation to use, let's import these into Unity and set up a scene. Immediately, you can tell that there's a few things wrong. And I know some of you will know one of the reasons being the import settings for our sprite. So let's quickly go to the sprite location and fix these up. We'll first set up the filter mode to no filter, and then set the compression to none. It's looking a little better, but the sprite still seems off. And that's because we need to fix the pixel per unit setting. We'll update this value to be 32, and it looks like our sprites are at the correct size now, but there's still an issue. These sprites aren't really resembling anything. There's missing pixels, they're super enlarged, and they don't have any clarity, which takes us to our next point, finding the correct camera setting. Unity's camera has two main projection settings, perspective and orthographic. Now, for the purposes of 2D games, it is much easier to set it as orthographic, as it means we don't need to deal in the third dimension. Now, again, there can be a case for perspective views, but doing this means you'll have to deal in the Z axis and the correct field of view, which for moving scenes can be a bit difficult. So let's set our camera to orthographic. And the only value we want to focus on is the size. And fortunately, instead of trial and error or slowly moving the slider to find the most correct camera size, there is actually a formula that we can use, which is the screen height divided by 2 times the pixel per unit. For our example, our resolution is 240 by 160, so our height is 160, and our pixels per unit is 32. So if we plug all of these values into the formula, we get a nice clean 2.5. And if we use that in our camera size, we can see our sprites come to life immediately. It's common these days with seemingly all forms of technology to advertise the classic RGB multi-million color possibilities. And with the tools used for pixel art, these colors are at your disposal. But it's not always a good idea to make use of these colors. Sometimes less is better. Let's take a look at Pac-Man on the arcade. First noting the resolution of 224 by 288, which was a common vertical resolution used for arcade games, which closely fits a 4:3 ratio. The next thing to note is the limited color palette, a purposefully done choice by the developers, but it was also because of hardware limitations. An arcade machine didn't have the graphical intensity to be able to process high bit resolution, so developers would have to stick to a lower scale, with video games starting at around 8-bit, meaning 256 color possibilities. But being able to render 256 colors is another story. So again, coming back to our constraint, developers opted to utilize the strength of this new 8-bit technology, but only have it render from a limited palette, with Pac-Man using a limited 16 color palette. But what would it look like utilizing 256 possible colors? I spent some time experimenting from this screenshot and came up with this. And to me, this looks pretty ridiculous. There's definitely more life to it, but the charm of the game disappears as a result. It just feels a bit too busy, like there's too much to focus on and can almost overwhelm the visuals. So an important thing to note is that less can be more. It's also important to definitely do some research into color theory. There are colors that work with each other and there are some that just look bad. So spend time even before making your game thinking about what kind of palette you want your game to have. Unfortunately, we do have the multi-million color possibilities, but finding a maximum number of colors to use will definitely improve your game's visuals. But it'll also give your game a style as well while helping you with decision making. You're working within a constraint, so being overwhelmed with possibilities can negatively contribute to the process of your game's design. Now, putting all of these together into practice, you should be able to see your game's visuals improve quite significantly. But there's one more thing that I'll touch on, and that is visual consistency. I'll preface, there is a case to be made for some inconsistencies. Again, it comes down to your game's design, but keeping a consistent style from the game's art to the game's interface can make a huge difference. I'm going to set up 2 identical scenes in Unity, but I'm going to use 2 different GUIs. One will be consistent with our pixel art, and one will just use a more modern, higher definition look. Now, side by side, although neither scene looks terrible, the one with the consistent style definitely has a charm which to me just looks a lot better. Imagining the entire game with the inconsistent style, there's definitely going to be parts that just appear more jarring or out of place. So, consistency is key. I hope you guys learned a little bit today, and I hope that using these tips, you're able to improve the style and design of your pixel art game. If there's any tips you want to share, please leave a comment down below. I know that all experiences and knowledge will benefit this community heaps. If you enjoyed this video and want to see more like it, join the community by subscribing to the channel and join my Discord. If there's any tutorials, whether that's Unity, C# or pixel art that you want to see in the future, let me know down in the comments as well. Otherwise, thanks for a huge 2024, and I'll catch you all next year. Take care.